all. Let's move to the next topic in chapter 1, which is equation and function. Equation and function is something related to manipulating the variable, where manipulating the variable, we can obtain a certain value that we want. And you already learned about this before, which is a general equation of the equation function, that is y equal to ax plus b, where y and x given here is by a blue color, is a variable where we can manipulate the number of it, and b is the constant, b and a is the constant, and while a is the coefficient of s. Let's recall it back what we learned in metric level or in the secondary school, where this one is s axis, this one is y axis. For example, if we have like this one is 2, and we can find the a or the coefficient of s here, given by this one is 1 1, this is 7, what is 7 4. So if we can determine the value from the graph, so we will have y equal to 2x plus 2, y2 is the constant, and this 2x, the coefficient of x, we can get from the graph by using the formula m, or gradient, equal to y2 minus y1. y2 is 7, y1 is 1, over x2 over s1, x2 equal to 4, and s1 equal to 1. So 7 minus 1 is equal to 6, 4 minus 1 equal to 3, 6 divided by 3, we have 2 here. And for the variable algorithm that can take different value, they can vary. So here is our variable, so we can manipulate the variable and get the value that we want. Constant here, constant is a fixed number, they cannot be changed. For example, here the constant is the constant for s, or coefficient of s, equal to 2, and for b equal to 2. So this one, for the function, the constant or the coefficient cannot be changed along the graph, along this line of the graph. And for the another function is the coefficient of s is the constant before the s. In the same way for the equation, for example, we take this equation, y equal to x t square plus t, so the coefficient of t square is x, and the coefficient of t is 1. Actually, for example, we take our function before, y equal to x plus 2. Actually, we can represent the function as equal to y equal to fx to x plus 2. I believe that you've seen it before in many times. So how to pronounce it is y equal to f of x equal to 2x plus 2. So this is how we represent our function. And although we have we have used the notion of fs, so we can also use gs or delta s or any representation. So there is no reason why we could not use other functions. So for your information, or it's a common practice that we are commonly use y equal to f of s. Besides, in our function, the variable we can have a many variable in our function. For example, y equal to x plus 3x squared plus 5z. It's not a problem with that. So in our function, we can use more than one variable. So one example for you to do for us to familiarize what we learned before. So in an experiment, the pressure of a gas is monitored as the temperature is changed, while the volume and amount of gas remain constant, and the following relation was established. P equal to 0.034T. So here we can identify the variable and coefficient in the equation. So our variable is P and T, while our coefficient is 0.034. So if we want to make the function, or the second question, what is P a function of? So what we can do is P equal to function of T. So for example, and for the third question, given that T equal to 343, what is the value of P? So what we need to do is we just plug in the number into our equation. So have um, so we calculate it and we can get the value. So the value will be 11.662. Move to the next topic, which is how to derive the ideal gas law, which is we always use, or in chemistry this is a popular equation, ideal gas law. So what is the ideal gas law? The actually is the relationship between the pressure, temperature, volume, and amount of gas. So all this relation can be combined, and we can describe the behavior of a gas. So based on the ideal gas law, we will follow the Boyle's law, the Charles law, and also the Avogadro law. So here, the first one is the first one is the Boyle's law, which said that V or volume is inversely proportional with the pressure at the constant N and T, and is molar, and T is the pressure. The Charles law is V is proportional to temperature at the constant N and P, while the Avogadro law is said that volume is proportional to molar at a constant T and P. And when we combine all together, all the relation, we will get volume is proportional to molar and temperature. While it inverse proportional with P, so we'll have this relationship. So here is the link that I give it to you, so you can watch this YouTube video to get more clarification on what is ideal gas law is about. So let's derive the equation. So here is our equation that we get previously, and if we want to make it like this, what we need to do is we need to put the constant here. So V equal to N R N T over P. So how, and if we can rearrange the equation by using the Boltzmann rule, So we will have, so we move P to our left hand side, so we'll get PV equal to nRT. However, for the PV equal to nRT, we can also represent it in another way, where we can derive the equation. So if we still remember that molar equal to m over n, which is m is mass, divided by molar mass, so we can get the mole of the gas molecule. So what we need to do here is we substitute the n, and here with this equation m over m, mass over molar mass, so we'll have this mass over molar mass acting. So if you have this kind of problem, or you encounter the equation regarding this one, so what you can do is you can derive the equation from the ideal gas law to get and substitute the mole with mass over molar mass. So we will have this function, and we try to derive a few more equations in our tutorial class. So you can test yourself by using the ideal gas equation to solve this problem, where the Rieber equation equal to 0.0820574. So you can use this and value as your Rieber constant. So for the next, we will discuss how to derive the ideal gas law from this equation to this equation. So we discuss it in our tutorial class. So I hope you don't miss it. Okay, thank you.